All right. Good afternoon, everyone, and welcome to our Thursday LEAP lecture in climate data science. Today, I'm so happy to welcome back a fan favorite, our friend Chad Small. He's from the University of Washington. And so let me just read his quick bio. Chad is a fourth year PhD candidate at the University of Washington in atmospheric and climate science. He's researching teleconnections between tropical phenomena and mid altitude rainfall and flooding. He is a National Defense Science and Engineering Graduate Fellow, and he spends his time writing as an environmental justice reporter and science writer. His work has been featured in the Bulletin of the Atomic Scientists, GRIST, Inside Climate News, and other places. And in 2025, he was the AAAS Mass Media Fellow with Inside Climate News, and he holds a BS in Environmental Engineering from Yale and a Master's in Earth and Atmospheric Science from the City College of New York, a local partner whom we love. So, Chad, welcome.
Thank you. Can you hear me? Okay, there we go. I think all right, cool. Hi, everybody, happy Thursday. So my name is Chad Small. Thanks, Catherine, for introducing me. So today we're going to go through like the art and science of science communication for earth scientists, since many people here are earth scientists or earth science adjacent, to get you inside idea of how to do that and how that's meaningful or important. So I'm gonna go through the outline for today. So a little bit about myself and my background. Then I'm gonna go into like why science communication matters, how we do science communication quickly. Then we have three activities that we'll go through, which I don't think should take too long, but they should get you in the headspace of kind of how to think about how your research or science you care about can be important for people like near you who aren't otherwise scientists. Then I'll go through the end with some information on being a media source and just additional resources if you're interested in how to do more communication in the future. So yeah, about me. I'm rising fifth year PhD candidate in atmospheric and climate science, University of Washington. Kind of like Catherine said, I like study how tropical phenomenon impact mid-latitude rainfall extremes. I'm originally from New York City, so happy to be home for a little bit. Yeah, I'm a science writer and journalist when I have time, which is kind of hard sometimes when you're in grad school. And last summer, I was a mass media fellow with Inside Climate News. So basically, I spent last summer just writing and reporting about the environment, which is really fun. So I'm gonna get into more about my journey to science writing and communication to give you guys an idea of where I come from. Then we'll get into the workshop in a proper sense. So I'm gonna have a little timeline here of like from when I finished college until now to get an idea of like where I've been working. So if this will load, there we go. So I did my bachelor's in environmental engineering. So I worked as an engineer in New York City for about 2 years. And a lot of what I was doing was looking at remediation work in New York City. So the idea is like in the 30s and 40s, we got energy in New York City by like basically taking coal, burning it, melting it, and throwing the refuse into the ground. So that was kind of what I did for like the first years out of college, which was good to know how to do, but could be a little bit boring. So I was a little lost and had to figure out where I was going with my life in some ways. So after that, I kind of started getting into like science writing. I had a friend who was like, "Hey, there's this like position to do some environmental justice reporting. You know a little bit about the environment and you can write." So I applied for it and got it. So I did a little bit of reporting around New York City about just like climate, the environment. This story I wrote in 2019 was about how Hurricane Sandy recovery is working in Canarsie in Brooklyn. So I got it kind of got me more inspired to do more reporting and more writing and just more science communication. But it also got me into grad school in some ways. So this is more reporting. This one I did about like energy aggregation or like energy changes in Florida, looking at how you could like save energy on your household bills, also help the environment. But yeah, like as I was reporting, I was kind of thinking that I don't know enough about the things I care about reporting on. So I was like, let me get my master's in Earth atmospheric science, kind of figure out how to do that. So, like I said, I'm from New York City, so City College is like right here. It was really good, really great university to go to. So I did some research there, did some work in like studies there, mostly to figure out if I wanted to do more like physical science work, if I just wanted to like learn about it to like inform my writing or do other things. I ended up enjoying it, which is why I'm doing the PhD now. But while I was there, I did some other things too. I was NOAA fellow. I was at City College, so I did some work in Congress doing like policy work, which was cool, a different way of science communication also. Um, towards the end of my master's, I like was working my thesis, and then I started reporting at GRIS, doing a little bit of like more data journalism and just like environmental reporting, like in a more proper sense, like over time. And then I decided to go back to grad school. So then, kind of, I made my way to Seattle, and I'm doing my PhD over there to kind of like get deeper into the science. But I also done some writing and reporting while I was there. And then this past summer, it's very slow. This past summer, I was Mass Media Fellow through the American Association for the Advancement of Science, which basically funds a variety of things. One of those things is a fellowship for mostly like PhD students and some other science, like graduate students, to go into reporting and writing to kind of teach us how to communicate about science from a science's vantage point, basically. So this is kind of where I come from and where I am right now. And I'm going to go into kind of like how this informs why science communication is important and why it can help us all think about how to do that a little better. So why does it matter? So I'm going to show a little paragraph for you guys to like look at and kind of get into like how like explanations matter for science. So this is a brief description from a paper looking at how, discussions on climate change inform perception of climate change. So you will take a second to read it. So in short, this is kind of giving, I think, something that most people probably know, like how does climate change work? How does it function? What it does is it describes like what climate change does in a very clear fashion. And these kind of explanations are really important. And from this paper, what the researchers found was that if you have statements that are like that descriptive, you basically move public perception to agreeing that climate change is a problem. It shouldn't necessarily be something we have to agree with, but people have different views on different things, and convincing people is really important. And scientists' role in that is really important. Um, Similarly speaking, the Pew Research Center, which is a center that looks at public polling, which I'm sure you guys have seen, kind of did like a study looking at how scientists are seen by the general public. So what you notice here is like most people think scientists know things, but less than half of people think scientists communicate well, which is a huge problem. And how do we get that problem basically? So kind of tough time to be a science communicator or science in general. But these things happen. So we get into like how we deal with this and how we learn more about how to communicate about science. So I'm going to go through first a brief overview of what makes for quick science communication in an effective way. Then we're going to have an activity that I want you guys to do that could be a little bit fun, I hope. And then we'll just kind of keep it going from there. So first things first, how do we do science communication quickly? The first thing is just avoid jargon. Anything that you would talk to your advisor or a professor might be too complicated for the average person to understand. So think about how you would bring it down to a level that the average person might get, right? Also, just like be brief. Attention spans these days are short, mine included. And sometimes the quicker the thing you say is, the easier it is to keep in people's mind. Similarly speaking, it's like the idea of setting, right? If you're at a bar, a coffee shop, wherever, if you can explain it to someone there, that's kind of the level at which you want to be able to keep that thing in someone's mind. And similarly, like explain like you're five, something an editor once told me. The idea is to bring to level that a five-year-old can understand is really helpful for us to learn how to do science communication well. So with that in mind, we're gonna do a quick activity called Pop Talks. I think everyone here has the awesome and jargon placards on their table. Good. Okay, perfect. So this is from ComSciCon, which is a conference for science communication for grad students. And I think it's a good exercise to get people in the flow of how to discuss their science freely. So I said group, but like I'm gonna just volunteers if people are willing to do it in front of the room. Basically, one person's gonna stand up. You have 30 seconds to explain your research. You're gonna avoid jargon, and basically the handouts are gonna be like kind of like a group activity, right? So you explain your research to a group that will show in a second, and then people will wave the placards awesome or jargon depending on how you're doing. Like jargon being like you're using too much jargony language, awesome being like you're doing a great job of explaining what's going on. Um, so here are our groups you will have to pick from: kindergarten class, scientists in unrelated fields. So someone ideally similarly educated to people in the room, someone you met at a bar or coffee shop, but then high school social studies class. So high school students, but not necessarily in your domain. So I'm gonna put this here. So I'll give you an example. Let's say I'm explaining my research to someone at a bar, coffee shop, right? I can be like, hey, my name is Chad. I'm a graduate student. I study how moisture in warm, really warm places impacts rainfall in places that are a little less warm and a little more cold, right? I think that that's, and like I'll be saying that. You guys can wave your placards at me and saying awesome if it's good, jargon if it's bad. So it's kind of like the timer we're working with. So like, yeah, exactly like this. Just wave it up, just like, yeah, awesome jargon, like, yeah, just like that. Um, so I have little numbers here that'll pop up, but if any you, so you want to volunteer to get up in front of everyone in the room? I know it's a little scary, but I imagine we're all friends here.
Just pick people.
50 people. Let's see. I'm gonna actually know over there who's waving the awesome flag. Do you sorry to just call on you from the front. So I'm gonna just hit this here. So you get kindergartners, which I know is like pretty rough, but I think you'll be fine. So I'll have a timer here. So stand up if you want to. Also, what's your name, by the way? What's your name, by the way? Tito. Okay, cool. So you're gonna,
Um,
so ready to go?
so hi. Um, what do I do? What do I study? So I'm also a grad student, and so as kindergartner, I'm sure you know about AI, right? Okay, so awesome. Yeah, thanks. Uh, So the idea is that now we want to use AI to be able to help us protect climate and get more information about climate change. So as you know, climate is changing, and we want to know how bad it is changing. So we want to have predictions of climate in future years, future decades, and we can use AI to do so. And so I'm working on that, and there are several problems that I'm trying to fix right now to improve the AI doing that.
Thank you. Cool. I know it's a little scary. That's the whole point. The point is to make like kind of like icebreaker for everybody and stuff like that. But yeah, it's like as the audience, feel free to like wave them very actively. Let someone know they're doing a good job, or maybe they can improve. Anyone else who wants to go next? I'll call on people, so easier if people want to volunteer. Yeah, go for it.
So I'm in an REU program. I'm sure you know what that is on climate science and data science and unrelated scientist. And the point is to study the convergence of the two, where they intersect, and how each can be used to improve the other's field. And so I'm still learning what exactly that means, but I am really excited to get started.
Okay, four. High school social studies class. Let me think about this for a bit. All right, so hi everyone. My name is David. I'm sure in social studies class you study a little bit about maritime trade and the economics of shipping goods from one country to another. Well, one aspect of research that I do related to that is when you're on a trade vessel and you're trying to go from one place to another, you kind of have to worry about sea surface currents, right? And specifically the direction that they're going in, how fast they're going in, right? So, long story short, what I do is I use AI and something specifically called machine learning to try and guess what exactly those sea surface currents are across the world ocean and therefore help people who operate these maritime trade vessels optimize their routes, get to where they need to go in as little cost as possible.
Oh, great. Okay. And one more person, and then we'll move on.
Hi everyone. My name is Sabiha, and my research is involved in climate science and data science. And so the idea is to use AI and machine learning to improve climate models, specifically convection, which is dealing with storms and rain. So using machine learning to improve models and predictions for that.
Thank you. Okay, great. Thank you guys for participating. I know it could be like really scary and a little stressful to be in front of a bunch of people and explain your research when you haven't done that before. But the whole point is to make you comfortable doing that a little bit more often. So I have a question for the room, and this is like less stressful. No one's taking the research right now. But I'm curious, what do you guys think was the most difficult part of doing that based on the things here? You can raise your hand and feel free to just like shout out what you think was hard. Go ahead.
I think, one challenge of just extemporaneous speaking is we're so used to thinking about our work or our research in terms of what we need out of it or the goals that we're striving for. And it's just like a lot of cognitive load of, I guess, trying to like empathize with your audience on the spot to think about, well, what about what I do is most relevant to what they might be curious about or they need. But it's a wonderful challenge, and it's fun to do over and over again to get that practice.
Other thoughts, questions? We thought was difficult, maybe easier, perhaps. Go ahead.
I feel like something difficult.
I felt like something difficult for me, especially because I was supposed to talk to a kindergartner, was knowing what they could understand and what I could actually say. Yeah.
Yeah, the kindergarten one is honestly really hard because unless you deal with like preschoolers, you're like, what do preschoolers think about? Particularly because I think like that changes over time. You know, what I probably thought I cared about when I was 5 is probably not what a 5-year-old cares about now. So those are things to consider too. So I think it's also thinking about where your audience is relative to where you might have been at that same stage. Any other thoughts before we move on to the next thing?
I would just offer, I think the coffee shop one could be difficult because depending on who you end up meeting, you can see in their eyes when they shut down, right? It's like, when you meet someone and you're like, oh, what do you do? And they're like, oh, I'm a death doula. And it's like, oh, well, and that's the end of the conversation. And so I could see how, depending on who you meet, if you say, I'm a data scientist, someone could get very excited or someone could just shut off and go, okay, that's nice for you.
Yeah, I think that's a really good point, actually. I think what I try to do, it's hard all the time because sometimes people have different interests. It's like, what is the part of the thing you do that they find interesting, which might just take some time to feel it out, basically. So the next activity I think should get us in this headspace of how to find that thing that people think is interesting. So something that we think about a lot is like, if as a scientist, you're like always taught science is everywhere. You're doing your one thing, but everything's science, right? How bodies function is biology, how things move is physics, right? There's chemistry everywhere, right? Like it's ubiquitous. But I think something that was mentioned before is that scientists, we're kind of trained to think about our one domain thing really narrowly as we move forward through things. And that makes it kind of hard to get other people interested in what we're doing, right? How do we make that like more vast is I think a big question. How do we get beyond that? And I also think like it's talking to another scientist might be easier because other scientists are doing science, right? They might not be doing what you're doing, but might find the process interesting. But I think the big question is how do we make this work interesting to non-scientists? So I think we're gonna do an activity to kind of figure out a little bit. So you guys should have, so how many people do we have? Let's break into groups of 3, if that's cool with folks. 4, because you guys are over here and all like 2 and 2, but like let's get in the groups of 3 or 4, like nearest people to you. And you're gonna pick one community to focus on. You guys should have like worksheets, and one of the worksheets should be like identifying science community. You're gonna pull that one out, and you're gonna pick a community. It could be where you live right now, the community you come from, any of those communities to keep in mind, and it could be a group idea of which makes more sense. And what we're gonna do is we're gonna go through the questions on that and kind of answer them. Take like about 10 minutes. We'll come back and share out what people are thinking about over the next 5 or 10 minutes after that. But the whole idea here is to get you really an idea of thinking of like what does community care about? How do you figure out how to make your science relevant? I'm gonna give you an example first, because this is kind of throwing you in deep water of like how I think about this and let you get into it. So I'll give an example from a story I wrote that came published recently. I did a story looking at how they're using like AI tools in Washington State to find wetlands to protect them and stuff like that. And basically conservationists, state ecologists, agricultural interests are all using this AI tool to kind of find wetlands that might be hard to find in Washington. There's different reasons why that's hard to do. Here's a QR code if you're interested in like reading the story at some point. I'll bring it back up after if people want to read it later. But basically, I'm going to use this story as an example of how I think through the questions I just gave you on that worksheet and kind of how you would do that and stuff. So the first question I have is, what industries are in your community, right? So for this story, I was like, it's timber, there's farming, remote sensing, and just tech broadly, because Seattle's a big tech hub, right? It's like, what are the climatological and environmental factors that shape this community? So Washington's a weird state. Seattle people think of as rainy and green because it is on Western Washington. Eastern Washington is actually can be a lot drier in summer, more like a desert kind of climate. What conversations are people having in this community? So, wetland conservation is a big question in Washington. Agricultural maintenance is a big question. So the idea of how do you keep farms going? Washington grows a lot of like apples and things like that that are really important to the economy. And then housing availability, right? How do you build more housing if the housing might flood? What issues are coming up in political bodies, right? City planning, city council, stuff like that. In this case, it's like, how can Washington build more housing, right? How do we help agricultural interests maintain conservation goals? These are questions that are like being debated by politicians in and around the area. And then how do you make compelling for people? Why do people care? People like to care about other people. And so the big question here is, how do we bring farmers along in terms of conservation if conservation seems to be out of their business, right? Because conservation is usually asking people to limit their farm's growth as opposed to letting the farm keep going. So with that in mind, I'll give you guys 10 minutes or so to work through questions with your groups. So I'll kind of flow around the room to answer questions as you need to answer them, but you guys can feel free to go after it, and I'll just bounce around. So go ahead. Let's bring it back. Let's come back together. All right, cool. So I heard a lot of great conversations. Seems like you guys are really getting into it. So I kind of want to go around the groups a little bit and just let's just talk about what you guys came up with, what you guys what industries you guys choose, what issues you guys think were important there. I'm just curious, what you guys are talking about, basically. So maybe we'll start here and go around the room, basically.
So, hi. Well, the first thing we did was we all kind of talked about our work, and most of the work here is focused on extreme precipitation. We have some work on tropical cyclones. So we kind of agreed that a community that's impacted would be urban cities, people in those communities. So for our industries, because we were looking specifically at New York, but then we started getting to a really interesting conversation about how New York's dealing with things and how France is dealing with the same things. So we focused on finance, transportation, and construction, explicitly New York centric. And then we started talking about the climatological and environmental factors. We were well, it gets really hot here in the summer. Winters, we're seeing a decrease in snowfall. And then we didn't really get past that, but I think the conversation we had is links to the third question, because I was describing well, in New York City, we have cooling centers in the summer. We take a lot of precautions for our heat because we know it can be very dangerous for particular communities and vulnerable neighborhoods. And my new friends here, we're describing how in France, they don't have that. Or say in the winter when there is snowfall, and I think we've seen a decrease in snowfall, but we're always prepared for it. Where say if it snows in Paris, France, it freezes the city. Literally, no one can get anywhere because no one's prepared. So it's interesting because there's conversations happening with us about being prepared, and then in other places where the same thing is happening, there's a lack of conversation. And we didn't really get to the last two, but
yeah. That's great. I mean, I'm happy you guys are just talking about general. I mean, even the snow thing. I live in Seattle now, and we get maybe 3 inches of snow a year. Whenever it snows, the city just shuts down entirely in a way that New York just doesn't. So it's very interesting how different places deal with different kinds of weather and stuff like that. Awesome. Thank you guys. Cool. Let's go to the next group and back over there.
we basically talked about data centers and the environmental impacts it can have on local communities, particularly as it pertains to water usage and water availability. And I think looking at the economic aspects of it as well was also very relevant because a lot of the places where data centers are being built are places that have otherwise been deprived of economic opportunity or lacked substantial industry. So data centers are obviously pitched as a way to bring jobs and economic investment to that location, but whether this is actually the case is deeply contested. And we also discussed the fact that data center construction and the resource intensity of all of this conflicts with a lot of other sensitive issues like fair water use, water rights, electricity, etc. So it's a very deeply intertwined issue that's intertwined a lot of other issues. So it's quite complex to deal with.
That's a really great topic, I think, to bring up here too. We're getting to the next exercise, but hold on to that and think about how your science expertise might help with issues like that. I think that's a really good place to start. All right, let's go to, I guess, the group right here. You guys? Either here or there, either or. Yeah.
So in our group, we're all in the same research project. I think the main difficulty is that our project is very specific to a particular type of problem involving cloud microphysics. So our difficulty was connecting it to like these bigger picture ideas that are on the exercise questions. But I think what we did come up with is that I think having more accurate predictions of these microphysics will lend to things like maybe more accurate weather predictions, maybe things like natural disaster, like tsunamis, snowstorms, hurricanes, things like that. So I think that's like kind of impacting the broader world. In terms of the communities part, I think we mainly focused on how this project actually involves a lot of different disciplines from machine learning to physics to climate science. So I think those were like the most immediate relevant communities.
That's cool. So how would you guys, I guess, like you're thinking like communities as like kind of places where like disciplines where people work in? Would you extend that to places where people live too?
Like location.
Yeah.
So like I think it could be applied anywhere. Like there are some more disaster prone regions than others, which would I think the focus should be on there. But I don't think there's like one specific location per se.
Thank you guys. All right, you pass this to the next group next to you. Yeah.
Our group was talking about the urban heat island effect. We've been in New York for a little bit, and it's pretty warm, but we're nowhere close to the peak of it yet. And I remember last year I was in the city, and it hit like 95 to 100 degrees for like a week or two straight, which was pretty alarming. And I've grown up here my whole life, and I could tell like it's only getting worse and worse, and that's surely due to the fact that like climate change is getting worse and worse. And the urban heat island effect is pretty real and intense in New York, especially because there's so many skyscrapers, there's so many buildings. But obviously, like to change something about that and change like sustainability or like climate initiatives, it's not at the top of everybody's list. Like, of course, our mayor and like our government are going to care about like putting food on people's tables, right? Like housing issues, just basic necessities issues that definitely seem more important than climate change. But then if you ignore climate change, then those issues will only get worse. So it's like we were talking about like we don't really know like what the best way to deal with that is, but like that is like a big issue that we were talking about.
Yeah, I feel like this is the next exercise doesn't come up with the whole question of how do you leverage your science to get people to care or like or at least do something about it. 'Cause I think people care, but being like this is a priority list thing is hard, basically. But cool, awesome. Pass to the group right here.
So we were talking about Columbia students in specific, and for climatology and environmental factors, we were talking about like how students would like check the weather or the subway, the heating over there, and professors would also same thing, And the conversations that the people are having in this community would be, whether it be about clubs or student activities like sports or whatever it may be, and like even for sports like the climate could affect that, games could be canceled or whatever. And then issues that come up in political bodies. I mean, for Columbia, there's obviously like a student government, so stuff like that, or like the administrative board. Those political conversations could be coming up. And what are some compelling need to be told? I think we talked about like how there's like a gap between like sometimes Columbia will accept either low income students or like super like top 2% or whatever, and then those conversations could obviously be from two different like sides of the world, and those can obviously be kind of compelling in that sense.
Cool, thank you. Yeah, I think the sports one's really important. I think the World Cup now, a lot of people don't play in heat like this, and I think they're experiencing it right now. So awesome. That's okay. These are all great. Cool. This is fantastic. So we're gonna move on to the next thing, which I think builds on this one. So you have another sheet that's like stay in the same group you're in. Keep the same community you've been thinking about and the ideas in mind. What you're gonna do here is try to like almost build a science explainer, basically. The idea is like you kind of walk through what communities you think are important, what issues might be relevant to them, and now you're gonna like kind of bring your science in and be like, okay, how do we make our science relevant to people in this community to make them care about it, basically. So I think this will be from now to the end of the time we have today. Take like 10 minutes and we'll talk about it at the end. I have a little QR code in this Google form. If you have time, you want to put your group's answers in there. I'm happy to review them later. Up to you guys, like really a choice if you want to. But let's like get started. Like I said, refer to the other sheet and just like go at it. And if I have questions, if you have questions, just come find me. I'll like kind of be hovering around the room and stuff like that. So yeah. Also, I'm pretty sure the same QR code is going to be on the, I think it's the bottom right. Like QR code on the sheet is actually the same one as this one, I'm pretty sure. All right, everybody, let's bring it back so we can like we have 5-ish minutes left. So just let's bring it back. Cool. So would love to hear what you guys kind of came up with. I'm just gonna go the other way this time, so this way around the room. So if you guys want to talk about like kind of what you came up with, what you thought was helpful to think about in this exercise. So we can start here and work our way backwards. Also, make sure the mic is it on? It should be like green.
Hello. Yeah, it's off. Okay, so the thing that I guess like I'm not gonna go by question, but the thing that we were talking about is like with regard to third spaces and like I guess the social ability of humans. We were talking about how more extreme weather, like extreme heat, flooding, rainfall patterns, can affect third spaces. Think about like the Knicks parade that's going on today, or like the World Cup viewing parties that go on in Brooklyn Bridge Park, or just outside in general, like LA Koreatown. That's like the concept of strangers with community is a thing that kind of can get erased by or like somewhat mitigated. Like imagine if it was like 110 degrees outside, no one's going to want to go to that, or flooding or rainfall, anything like that, and how that can contribute to loneliness in the future. And then the other thing that we were talking about as well is, I guess, sort of an answer to the second question. Do you want to say?
Oh, yeah. So the questions that come up like over and over as we do research is in particular, like when we work with AI is for environmental science. Yeah, AI is also affecting the environment in that sense. So it's kind of a bit of a contradicting thing to think about, but that's just a question that will come up every now and then.
Sorry.
Well, that's great. Yeah, I think that the third spaces question is interesting, particularly with sports. I mean, I love sports a lot, and I think that congregating is hard. You know what I mean? I think there's like whole questions of like, can you play certain sports or places anymore, even watch them because of weather, like the whole last World Cup was in Qatar. They just changed the time of year, things like that. So, but yeah, I think great ideas and everything like that. Let's pass it behind.
Okay, okay. Um, okay, yeah, we were still talking about the idea of like the urban heat island effect, and we were looking some stuff up, and we were happy to see like there's a lot of like good scientific development in terms of like how people will construct like future buildings or like new buildings, and a lot of that is like changing building materials, which can reduce the heat island effect, so that like heat is absorbed less and like reflected more. And a lot of new buildings being built are introducing like smart roofs, which are designed to like maximize like the amount of solar like reflectivity, which we thought was pretty good. Um, some misconceptions we were thinking about is just like everyday people just don't generally consider this effect at all. Like they don't even know it exists. Like they go about their days like just like not knowing about it. So like we feel like educating people about this so then we can then inform our policymakers to actually make a change about it. We thought that would be like pretty important. Um, and last question, how would you break down the complexity of this chosen topic? We said that we should like follow the tips you said, explain in a way that easily allows a non-scientist to understand how your work will help society. Like obviously your work will be extremely specific to a topic, and like if you only explain that, then they're gonna be like, what, like how does this affect me? How does this help society in general? So if you explain like your broader implications, then that's gonna like hook them in more.
All right, thank you. That's awesome. And I think we probably only have time for like one more group, given that we're almost at 1 o'clock. So yeah, if you get one more, then we can discuss it.
Yeah, so for a recent scientific development, without like going too deep into the weeds, basically the method of prediction of like these clouds is getting a lot better. Specifically, like they're getting more granular. Um, so like we're kind of working with like the newest methods and then seeing how we can improve them further. For the second question, something that comes up over and over is the quality and accessibility of data. At least for our specific problem, you need a lot of it to get something meaningful, and it seems like that's currently the bottleneck, not necessarily like our approach or the methods we're considering. So I think that's like an interesting problem. A common misconception is that I think for the most part, people don't really think about like what we're like cloud microphysics. So I don't think there necessarily is a misconception. But if I were to explain this to someone, I don't think we're not predicting like exactly what's going to happen. We're just predicting like what's likely to happen. And I think those are like two very different things. And then that's how it ties into the last question. That's exactly how I would break it down in terms of complexity. Like it's just a prediction of what probably would happen rather than this will exactly happen.
Yeah, I think like the whole difference between we're giving you a probability versus like an actual like this is gonna happen is really difficult for people to understand if they're not like in like a lot of quantitative sciences. So I think that's like a really difficult thing to like condense down, but really important for what you guys are saying. Cool. So we're basically at time. I'm just gonna go to the last slide so you guys can like if you have, you know, comments and feedback. You can like skin us if you have feedback, but it's 1 o'clock. Thank you guys. Feel free to just hold on to. You have the worksheet that's yours. They're yours to keep. The top right corner has a QR code for the open notebook. If you have more resources about like science communication in general, is on there. Yeah, if you did fill out the Google form with the last like exercise, I'll just send back some stuff to you guys if you guys want feedback on it or anything like that, or just like thoughts. But yeah, if you have any questions, like I'm here. Let me know if you have questions, thoughts. But yeah, thank you guys for coming today and just being really engaged. This is awesome. You guys were like really talking. I love that. So yeah, thank you guys.